So if we use tertiary alkyl halide, when tertiary alkyl halide reacts with sodium alkoxide, we get alkene. Instead of ether, we get alkene. Okay. Next, aryl ethers preparation, aromatic ethers preparation. So here aromatic ether is anisole, preparation of anisole. So in the preparation of anisole, we take aromatic oxide. Okay. So we get we take phenoxide, sodium phenoxide. Okay. Sodium phenoxide that gets reacts with alkyl halide and we get anisole. So this is sodium phenoxide. Sodium phenoxide with methyl iodide. Here we get anisole, methoxybenzene. Along with this sodium iodide. So this is the preparation of aromatic ether. Next, coming to physical properties. Next, physical properties. So ethers, they are colorless liquids with a pleasant odor. Okay. Then coming to boiling points of ethers. So boiling points of ethers, they are less when compared with alcohols. Okay. For example, boiling point of ethers is less than alcohols. For example, diethyl ether, boiling point. So boiling point of diethyl ether is 34.5 degrees centigrade. Okay. Then boiling point of alcohol, ethyl alcohol is 78.2 degrees centigrade. So boiling point of diethyl ether is less than that of ethyl alcohol, even though it having the high molecular mass. Why? Because ethyl alcohol forms intermolecular hydrogen bonds, whereas diethyl ether, it does not form intermolecular hydrogen bonds. Okay. So that is the reason between this. Then coming to solubility of ethers. Diethyl ether, it is also partly soluble in water, water soluble. Why? Because with water it have a capacity to form hydrogen bonds. Okay. So partly soluble in water due to the formation of hydrogen bonds with the water. Okay. So this is solubility. Next, coming to chemical properties. Chemical properties of ethers. So first reaction with hydrogen iodide. Reaction with hydrogen iodide. If you take diethyl ether. So when diethyl ether reacts with hydrogen iodide, we get alcohol and alkyl iodide. Okay. So diethyl ether with the hydrogen iodide. So products formed here is ethyl alcohol and ethyl iodide. Okay. So diethyl ether, this is symmetrical ether. If unsymmetrical ethers are there, for example, methyl ethyl ether is there. Methyl ethyl ether. If it reacts with hydrogen iodide, okay, iodide ion, halide ion, that links with carbon which having more number of hydrogen atoms. Okay. So here oxygen is ethereal functional group. This is called ethereal oxygen and this is functional group. Oxygen links with 2 carbon atoms here. This is methyl and ethyl group. Ethyl means we can write CH2, CH3. Okay. So direct linkage of carbon having only 2 carbon atoms and here methyl group having 3 carbon atoms. When it reacts with hydrogen iodide. Okay. So iodide ion links with the alkyl group which having the more number of hydrogen atoms. Okay. So that's why we get methyl iodide and ethyl alcohol. Okay. So formation of methyl iodide and ethyl alcohol takes place there. Okay. Next, one more example for unsymmetrical ethers. So this is the ether. Okay. So 2-ethoxypropane. So IUPAC name is 2-ethoxypropane. Okay. When it undergoes reaction with hydrogen iodide. Okay. So in unsymmetrical ethers. Okay. Iodide ion that links with carbon which having the more number of hydrogen atoms. See here, this is the ethereal oxygen and this is the direct carbon linked to this. It having only one hydrogen atom. Whereas in C2H5 means CS3CH2. Okay. So carbon directly linked with the ethereal oxygen having more number of hydrogen atoms. That's why iodide ion gets attacks at C2H5. So we get C2H5I. Okay. Ethyl iodide. Along with this secondary alcohol. To propanol. Okay. So this is very important. When unsymmetrical ethers are there, when they reacts with hydrogen iodide, iodide ion links with the alkyl group which having the more number of hydrogen atoms. Okay. Then coming to aromatic ethers. Aromatic ethers. Next with the aromatic ethers. Hydrogen iodide reaction with the hydrogen iodide. So this is anisole. It reacts with hydrogen iodide. Here also iodide ion that links with the group carbon which having the more number of hydrogen atoms. So we get phenol along with methyl iodide. Alcohol here formed is phenol. Next, with the excess of hydrogen iodide. For example, diethyl ether is there. Diethyl ether. When it reacts with the 2 moles of hydrogen iodide, we get 2 moles of ethyl iodide along with the formation of H2O. Okay. So this is with excess of hydrogen iodide. Next, coming to electrophilic substitution reactions in aromatic ethers. Okay. Anisole. So chemical properties of anisole. So which are electrophilic substitution reactions. Okay. Electrophilic substitution reactions in anisole. So anisole, it shows 5 different resonating structures. Okay. In those 5 different resonating structures like phenol, at ortho and para position, electron density is more. Okay, ortho and para. That's why we get a mixture of 2 compounds when anisole undergoes electrophilic substitution reactions. Ortho substituted compound and para substituted compound. Okay.